two lines are perpendicular whenever one line can be rotated 90 degrees onto the other. But remember that a rotation doesn't move only the points on the line, it moves all the points on the graph. So we consider the relationship of the slopes of perpendicular lines, which can be demonstrated as rotating any line 90 degrees. So let's clear up this illustration and let's consider the distance between D and E to be A. And let's consider the distance between A and E to be B. And we only need one B here. So if you're familiar with the terminology rise over run, or change in y over change of x, then we can consider the slope of this red line, which passes through the origin at 0, 0, to have the value a over b. So can we say for a line, what would be the name of this red line? AD I don't see a fraction tool, so we'll use A divided by B. Because A represents the rise, or the difference in the y's, and B represents the run, or the differences in the x's. So then, what do we got going on over here with the slope of the green line? Well, now the change in the y's is b, the segment that used to be here on x, and the change in the x's is a, or the segment that used to be here. So if the line has been rotated 90 degrees, we know that it's perpendicular, so let's go ahead and mark the right angle. And I'm going to do this with the angle tool, and I'm going to check the points in alphabetical order. Oops. Use the move tool to move that label just out of the way. So we believe we have 4 right angles here. Let's talk about the slope of A prime D prime, the rotation of AD. So for line A prime D prime, the 90-degree rotation of line AD, we can see the slope is the opposite of the fraction or the ratio B over A, because at this point B represents the rise, or actually in this case it's a fall, and A represents the run. So the question then becomes, will this happen for every pair of lines that are perpendicular to each other? And I think that the 90-degree clockwise rotation proves that, yes, it will. If we rotate around a point, this triangle one more time around this point, 90 degrees clockwise, then my rise is A double prime. That still has the value that A has. And my run I guess I want to show the caption. So let's turn this off, not label. It's really B double prime. No, I'm doing this wrong. Object properties, show label, name, B double prime. Okay, here we go. So each of these slopes for each of these lines is determined using simply the rise, or the distance in the y direction, vertical direction, divided by the run, the distance in the x direction or horizontal direction. Rise divided by the run, rise divided by the run. And if we rotate this one more time, well, let's do it. This triangle around this point, 90 degrees clockwise. I'm getting my text box and not my segment. So I now have a run that's equal to B, a rise that's equal to B, a run that's equal to A. So we can calculate the slopes of, this is what they mean in question 1-71, where they say a non-special line. So I'm just going to erase that one reflection so we can add to the text box. So the important points here is that two parallel lines have the same slope and two perpendicular lines have slopes that are opposite and reciprocal. So the signs are opposite, and what was A, or what was in the numerator, is now in the denominator, and what was in the denominator is now in the numerator. So that tells you if you know the slope of one line and you know that there's another line perpendicular to it, you can simply calculate or see the opposite reciprocal and use it in the equation of the lines if you're using those equations well. So let's keep going. Let's keep going through 1-7-2. So here I'm just going to add the notation 1-7-1, slope of perpendicular lines. This illustration matches this question from the textbook. Where's the move tool? Here we go. We're going to move to a new space for 1-7-2, where it says, now that you know more about the slope of parallel and perpendicular lines, revisit the reflection from problem 1-6-8 and confirm the relationship using slope. So we're just going to follow the directions. Graph the triangles onto graph paper so that You have points P, Q, and R. So open up your textbooks to question 1-72, get some graph paper out, and go ahead and graph those according to those directions. In order to do that, I'm going to go ahead and turn the axes back on and the grid on. I guess I'm going to open a new file. Okay, so I need point 2.5, 3.5, so I'm going to get close if I can. And I'm going to go back and change the properties of these points so that they match the coordinates in question 1-72. And Q is going to be 1, 3, and R is going to be 0, 1. That one's easier. So what do? I go to properties, and this one is supposed to be 2.5, 3.5. I got the 3.5 right, so let's change this to 2.5. And we would like this point to be called P. And this point is Q. So I'm going to change its name. And it's at 1, 3, that's good. And I have a point R at 0, 1. Make the polygon. I don't need those labels, so I'm going to turn them off. And let's create the line of reflection so that we can reflect PQR to get P prime, Q prime, R prime. So my line goes through the point 2, 0, check the textbook, and also goes through the point 3, 2. Oh, that looks like it's about here. And I'm going to change, yeah, 3, 2, that's good. A line of reflection tends to be a dotted line. And let's reflect. PQR through this line. And we should have points P prime at 4.525, Q prime at 5, 1, and R prime at 4, negative 1. Okay, so we have the illustration. Then use your ruler to draw these 3 dashed lines, P to P prime. And you're doing this with paper and pencil. Q to Q prime, and R to R prime. And we're asked in question 1-72A, what is the relationship of these 3 dashed lines? Use your knowledge of slope to verify your observations. Let's put the grid back on. And you're being asked to calculate using the x and y values for P and the x and y values for P prime what the slope is for line P, P prime. You're also being asked to do that for Q and Q prime. So here are their values. And you're asked to do that for R and R prime. So 1 minus negative 1 is 2. 0 minus 4 is negative 4. The slope for R to R prime then is negative 2 over 4, or negative 1/2. Can we determine that? The slope is clearly negative. Down 1, down 2, over 1, 2, 3, 4. So from Q to Q prime, we see the same slope as from R to R prime. P to P prime is a little more difficult to see, but take a look at 3.5 minus 2.5, there's 1. 2.5 minus 4.5, there's -2. So we can say the slopes of each of these 3 lines is -1/2. Therefore, these 3 lines are parallel. And that's exciting news. In B, we're asked to focus on the relationship between the lines of reflection and each of the segments connecting the point with the image. So this is an illustration you've already made, right? What do we know about if these lines are parallel? What do we know? If we know about one, what do we know about the rest of them, that each is perpendicular to the line of reflection? And in C, you're asked to confirm that the line of reflection is perpendicular to the line segments connecting each original point and its image. So this is a line that has a slope of rise of 2, run of 1. Oh, I've misspelled parallel. Let's fix that. If the slope of the line of reflection is 2/1, can we determine with certainty that these segments are perpendicular to the line of reflection? And we can. So since the product of the slopes of these segments multiplied by the slope of the line of reflection equals -1, we can say that they are, in fact, opposite reciprocals. So the relationship between slopes of parallel lines and slopes of perpendicular lines, and how to use the equations of lines, either slope-intercept or point slope form, how to use these is going to be important in the next take-home that's assigned. So it is due a week from Monday. It's algebra review. There's 46 points available. These are performance points. Let's make sure you're picking up as many of these supported performance points as you can and get some help on how to use slope-intercept or point slope equations of a line with a calculated slope and your knowledge of parallel lines and perpendicular lines and the relationships between their slopes to collect all those points.